In this problem, we have just one force, and we want to find the moment around point O. So we're only going to have to do one of those cross products to solve this. So what we're trying to find, moment around O. Again, the moment is a vector, so make sure you're writing it as such. And we need a diagram, again, not free body diagram. In this case, we're not in equilibrium yet. We're not there until chapter 5. But we still need a diagram that's going to help us write the equations from this. So I'm going to draw this in a little bit more 3D view, just so we can see how this is working. So we have some bracket here. We're applying a force at A. We're trying to find the moment around point O. So that can represent the bracket. So in this one, we're told F, we're given F in its components. So negative 2I plus 5J plus K newtons. And because we're in 3 dimensions, I'm going to just go right away and put the coordinate down of A. So A, we have to go 3 in the y direction, so 3J, oops, that's right, in coordinate form, so 0, 3, 10 meters. So one force, A, O is the origin here, so that's where we're going to start. We're trying to find the moments around point O. So what's the equation we're going to use to find the moment around point O? Right, so generically R cross F, so let's start there. Okay, so the moment around O is going to be an R cross an F. Again, which R are we going to use for this? Yeah.
O to A.
Right, so it happens to have the same naming as the slide was, but what we want to think about, this is the position vector we want to use. It points from the point we want to take the moment about to where the force is being applied. So in this case, it goes from O towards A. So ROA is the moment arm, we call it, that F exerts to find the moment around O. So from O to A, we want the moment about O. The force is being applied at A. So as we saw in chapter 2, to take a cross product, at least the way I showed it, you want to use, you need the components of each of the vectors in order to do this, and then we use the determinant. So F, we're given the components right off the bat. So we have this already in component form. ROA, we do not yet have in component form. So before we can do this step, we first have to write ROA. So what is ROA going to be? Right, so it's the end point minus the start point. So remember, that's how we find position vectors. End point minus start point, so we can use the coordinates we have set up there. So 0I plus 3J plus 10K. So the coordinates of A minus the coordinates of O, in which case is the origin, so it's 0, 0, 0. So that's ROA, it's a position vector. And one thing to keep in mind, and I'll stress this in the next example too, this is a position vector, not a unit vector. So this will have units of meters with it. So it's position times cross force. We have that in component form. We now have this in component form. So now we can write this cross product the way we did in chapter 2. All right, so the first line is IJK. So what do I write on the second line of the cross product? So what numbers do I put in, or what values do I put in each of these elements? Right, 0, 3, 10. Remember, so this second row is the first thing I'm in the cross product. The third row is the second element in the cross product. So the components of R will be 0, 3, 10 meters. Right, and then the last row, I just put in the components of F. So I was given that, so negative 2, positive 5, 1 newtons. Again, the order matters. R is the second row, F is my third row. My first row is the IJK. So like we saw in Chapter 2, we're going to expand this using cofactors. So as a refresher, to find the cofactor in front of I, cover up the I row and the I column, and copy down everything that's left. So 3, 10, 5, 1, minus the cofactor in front of J, 0, 10, negative 2, 1. And then K will be 0, 3, negative 2, 5. So we have a cofactor in front of I minus the cofactor in front of J plus the cofactor in front of K. So the last step is converting these cofactors into, or simplifying them down, or doing that process. So what is the coefficient in front of I going to be? Right, negative 47. So remember, it's 3 times 1 minus 10 times 5. So negative 47. What will be in front of the J? Yeah. 20. Right, so this is 20, so we minus positive 20. Right, so the cofactor gives us 20, but remember we're subtracting that cofactor, negative 20. And then lastly, what do I have in front of the K? Right, plus 6. 0 times 5 minus negative 6 is positive 6K. And this is a moment, so it has values of, or units of Newton meters.